Hi, this is Fabian Landry, and this is CodeDoc by Feel It. In this part of the CodeDoc story, we're going to talk about the key differences between F sharp and C sharp. We're also going to walk through the different implementation of the Workday Calendar from our previous session. Now we have two projects set side by side. One of them is an F sharp project, and the other is a C sharp project. On the left hand side there we have the F sharp project, and on the right hand we have the C sharp project. We thought we would do things a little bit different this time. We basically not gonna code together. We're gonna have a walkthrough. That basically means that we're gonna walk over the code that's already implemented. We're not gonna go through the same thing we did in the previous video with C sharp. The F sharp code was coded by me personally. It's a port of the affiliate Office Workday Calendar coded in C sharp previously. Before we get started, I thought we would differentiate key differences between C sharp and F sharp. F sharp is an open source, cross platform, functional first programming language. Functional first is simply that it supports functional programming, stakes most of its functionality on that, but it also supports object oriented programming, such as C Sharp does. Functional programming has pure functions. It means there are no side effects. What's meant by that is that a function is supposed to do what it's meant to do without affecting other parts of the system. In F sharp, functions are treated just the same way or better than other values. They can be passed into other functions in a way that is unmatched by C sharp. On the other hand, asynchronous code runs faster on C sharp, but it's more lightweight on F sharp. The ordering of files matter in F sharp. There is immutability by default. Immutability basically means that a value cannot change its state once it has been set by default. It can only be replicated. There are ways around it, but we will go through that later. In F sharp, we have a concept called pipes. They basically allow for coding without the use of any local variables. In F sharp, we only have expressions, whereas in C sharp, we have expressions and statements. In F sharp, we have a concept called type inference, which basically means that you can write more code without specifying the type of the variable that you have declared. In F sharp, we have a concept named discriminated unions, which allows for modeling of a business domain, for example, in a better way when using classes, records, enums, and interfaces. That would also result in simpler code and less bugs. So let's go back to our project. To open a project in Visual Studio, you will basically create a new project and select class library. Make sure that you have F sharp selected and click next. Change the name of the project name. We are not gonna do that because we are not gonna create a new project. We are gonna work on what we have already created. For the sake of illustration, let me just select add solution there, click next, and on the framework, instead of 7.0, we want this to be 2.0, just like the C sharp project, and press create. And that will lead us here. We'll probably have to change the name of the project file, of the FS file. So let's go right ahead and look at our files and go from the very beginning. In the previous video we worked on a C# project. It was based on the Workday Calendar. If you get a little confused during the course of this presentation, remember that you can always fall back to the top here to know which language corresponds to which file. The Workday Calendar is for C# and Workday Calendar _F# is for F#. So now let's go start with the comparison. On the C# we have using statements. This is basically invoking the namespaces that are needed by our program or application. Whereas in F# we open the needed namespaces. We can see already from the beginning of the file that on the F# implementation I only used 2 different namespaces, whereas the C# implementation I used 4 different namespaces. Let's move on. We determined that our calendar will be of type Gregorian, and that's basically the same setup we will use for F#. Now let's look at defining month types. Our month types in C# is of type enum, which shows from January to December. On F#, our month type is also of type enum, and this is the syntax to create an enum. We have the pipe operator here after the equal. Let's move on. The next step is defining the holiday class. The holiday class on C# is defined with properties we get and set accessors. On F# we define a class that has update possibilities by defining a new constructor that takes in a holiday class as a prototype, day of the week, day of the month, month type, year, and is recurring. Note that these annotations or definition of the type of variable isn't actually needed because of type inference, but I added it on F# for you to see and not create too much of confusion. We could already see that the way we define the holiday on C# is kind of simpler with less code. But the code we use to define on F# because of immutability by default is not that much more complex either. What we do here is define day of the week, day of the month, month type, and year and is recurring as option type. They are optional. And we define equal to a holiday that takes in a default arg method. This is a method that's part of the Microsoft F# core operators namespace. And the method takes in the argument, which is day of the week, and the default value, which is this prototype.day of the week. This basically means that if these values and either of these values are not set, the value that is defined in prototype will be used instead. And then finally, we set them to the equivalent of the instance property. This is what we have defined with this day of the week. When we define it as member as like this, we're basically saying that it's publicly accessible. Let's move on. Now let's look deeper at the Workday Calendar class. The first thing that comes up is the stored holidays, which is a list, private read-only, which we instantiate. On F#, we basically use a list as well. This value is mutable, and we can see that by the mutable specifier here. Every time we use let in the class, within a class, it is private. If I were to move this expression to the left, we see an error. The reason why is because let mutable stored holidays is not in the same column as the rest of the variables. Now, if I was to move the one below, we see now that it complains about the one below that. The one below that has been understood to be a child of the previous let. So we set things the way they were. In F#, a list is immutable, whereas in C# is a array list. But I made this list on F# mutable because it's actually a container which needs to store values that change over time. Let's look at the equivalent in C# for stored workday start time and stored workday stop time. Let's look at the type instantiation, and I use the time span struct as well here, but instead of newing it up, I use the from hours. I could have done the same on C# actually, but to differentiate them fully, I leave it like it is. Now we look at the regular holiday container. Remember, let within a class is a local variable. It's set as a list. This is how we define a list. If I wanted to define it as an array, I would have a pipe in here. Space. So now we have an array, but we don't want to use an array because an array conceptually is mutable. So we use a list instead to make things a little bit more interesting. The next thing we're looking at is the get stored holiday if it exists. On C#, it's implemented by the use of system.link. That's why that namespace is included at the top of this file. The get stored holiday if exists is implemented slightly differently than on C#. On C#, we check for null when we use this method on the value we get returned. Whereas F#, we don't want to check for null. So what we want to do is return option type holiday, and that is done by this annotation here. The last one specifies the option. We could also hover over the method to see that it returns, this is the return symbol, a return holiday of option. That means this option enables us to return a holiday or none, and that is decided by this try-find function. The try-find function takes in a list and returns the first element for which the given function returns true, basically this function. So if it matches any of the items in the list, it will return the item. If not, it will return none. That's basically one way to circumvent the lack of using nulls. This is the pipe forward operator. It's basically used to pass in values to other methods or functions. Let's move on. The next function or method we would like to look at is get stored recurring holiday if exists. We see that it's basically the same implementation but with is recurring used in the lambda expression and the year omitted as compared to the get stored holiday if exists. I've chosen to omit, not to use the option holiday annotation, but if we look at the function, we see that it still returns a holiday option. That is type inference. So the output value is basically inferred without us specifying it. And the same thing can happen with the input value, some input values. It would be hard for it to figure out that the date parameter we pass in here is of type datetime. So if I was to remove it, it will have a problem knowing what to do. Let's move on to the next. And that is holiday. We look how it is implemented on C#, and the same function on F#. This might look a little bit daunting at first when you look at it, but it's if you're familiar with some of the concepts, eventually you will probably understand this as well. We pass in the regular holiday container into list try find. That would return us one type of day of the week, if it exists. Then we pass in the function, the result from this try find, and if it has any value, that means if it contains one of the day of the weeks, we simply return true. If it's none, we return get stored holiday if it exists by passing in the date parameter. Then we pass the result of it to a function. If it has a holiday, then we return true. If there is none, we invoke get stored recurring holiday if exists by passing in the date as a parameter. The result of it we pass into a function once again. If there's any recurring holiday, we return true. If there's none, we return false. So this is basically the same as what is illustrated here, but I'll leave it up to you to decide if it's simpler to understand or not. Let's move on. We look at the get time span method on C# and the get time span implementation of the function get time span on F#. Here we set it equal to new time span, but we could basically do this. Remove the new. We save and we move on. We have the method get working day increment, which takes in the compute positively and returns 1 if compute positively is true, or -1 if it's negative, if it's false. So let's look at implementation of F#. We basically take in let increment by checking if compute positively is true. We set the increment equal to 1. If it's not, we set it to -1. And we return that increment. We could have simply just written this instead, and we would still be happy with our code without the use of a local variable. Let's keep it like this for reference. Let's move on to get next working day. We first look at the implementation on C#. We see that we set up the date to start date and get workday increment, and we go to a do while loop and add the increment, and we exit the while loop if it's not a holiday. We return the output date. Now let's look at how it is in F#. In F sharp, I'm using a mutable output date. I set it to start date, just like on C sharp. And then I set get increment to get working day increment by passing in compute positively. Then I set an initial value of is processing, that is mutable as well, and I'm passing it to the while do expression, which is the equivalent of do while because this value is set to true initially. So it will run this at least once, just like a do while. Add the output date with the number of days that the increment will be, that is either 1 or -1. And finally, we set is processing to is holiday with the parameter of output date, and we return the output date. This is virtually the same implementation as on C sharp. Now let's look at is within working hours. We see on the F sharp that the implementation is virtually the same. No surprises here. We look at the second implementation, the overload of is working within hours, and we see that it looks slightly different, but it does virtually the same thing. First we pass in the date to get time span, then we chain it to is within working hours by passing the result to is within working hours. Let's move on. Look at get next working start date, and we look at the implementation on F sharp. We're basically doing the same thing on F sharp. Let's look if we have a mutable output date because we needed to change values in the while loop. We could opt to replicate the value, but I don't feel that would be very efficient. We don't need a new data type, we just remove that. If you allow me, I would like to change the layout a little bit. And we are back with a slightly altered layout. Now if you get confused, remember the file names. The Workday Calendar is for C sharp, and the Workday Calendar _ F sharp is for F sharp. So now let's move on from where we left off. We set the output date here, just like we do on C sharp. The current time span is set by get time span. We make use of the var keyword here, which is another form of inference in C sharp. We use the move to next. We set it just like we do on C sharp. The same we'll do with increments. We call them increments in F sharp and Workday increment in C sharp. Let's go ahead and change it to Workday increment. So we have uniformity. We have move to next day implemented in C sharp. And we don't have such thing here on F sharp. I have an if else and return output date on both occasions. That basically means that I can go about simply removing this. Let me first copy this and removing this. And outside of the scope of the if statement, we paste in the output date. This should give the same results. So what we've done is we have moved all the checking outside of the while loop and enclosed the while loop with an if statement and return the output date at the end. We can basically replicate the same on C sharp. Let's go ahead and do just that. We have moved to next, and it's basically the same condition as on F sharp. We have Workday increment, which is the same condition. So now what we want to do is we will then surround this do while with an if statement. We just mark it and click on Control KS and surround it with an if. And we write move next or is holiday. Remove this and this. Now we have replicated the same implementation. I'll leave it up to you to decide whether it's better code or not. Alright. The next thing we want to do is move on to store holiday date. We are doing the same thing here in F# with pattern match over option type. We match the optional date against the condition, and we call the get stored holiday if exists if there is a value in datetime. That means if there's a value in optional date. Now, after retrieving the value get stored if holiday exists, we pass the result to a function. Then we check if that function has some value. That means if the returned holiday has a value. If it has a value, we perform whatever is in this section. It is part of the sum because it's indented and right below sum. If it doesn't have any value, which is basically the equivalent of found holiday be equal to null in C#, we perform the exact same task. Only difference is that we have an easier way of instantiating in F#, and the return value or the newly created holiday gets put in a list, and then that list is appended to stored holiday. That means basically it is added as the last item in the list. And what this describes is that the first list, which is stored holidays, gets provided as a parameter of the list append function, and holiday to add, which is the second list we've created and get passed into list append, gets passed in as list, the second list. List append says that it returns a list that contains elements of the first list followed by elements of the second list. The first list is stored holidays and the second list is holiday to add. And the result of the list append operation is passed as a function to return a stored holidays which is assigned to that very list. And then we return a unit. Unit is the equivalent of not returning anything, of a void method, indicating that is a void method in C#. Now let's look at any elements. If it's containing any elements, we check that if it is recurring, just like here, and then we perform an operation where we pass in the result of stored holiday passed into list map, and list.map allows to return a new collection whose elements are the result of the function that is passed in it. And the function we passed in it is basically saying that all elements should be as before except the element that matches this condition. That element we want to set it to a new holiday with recurring equal true. That is equivalent to what we see if it's not recurring. However, we want to return a unit. We could achieve the same thing on C#, but we chose to add here. That would throw an exception if it already exists, and we assume that it would be a framework error. If we got to this point, we should never get to this point, but we would achieve the same thing as we're doing on F# if we simply remove the else. That's it. And we also have a condition here with a non-returning unit. That is for the first scenario of optional date. If it's null, we simply return none. Let's move on. We have the get 24-hour time span function. That's simply set like this. Nothing too complicated there. The next function is get stored workday start time. Solve like this. That is a public method in C#, and that is translated to a member function. The same thing is done with get stored workday stop time. And with the enumerable get stored holidays, the way we did it in F# is simply passing get stored holiday. And we see here that they return a list of holidays, but lists are immutable in F#. So even though this stored holiday is mutable, we would expect that the get stored holiday function, which is not defined as mutable, will return a read-only copy of this value. Let's move on. We have set working hours, and that is simply set like this. The next method is set holiday. On F#, I simply just pass stored holiday calendar date false. Now the next one should be set recurring holiday. This is how it looks like on C#. Now let's look at how it looks like on F#. Almost just like set holiday, regular set holiday, just this time we set the recurring argument to true. Now let's move on. The final method, get end time based on working day increments. Now let's see how it's implemented on C#. We'll quickly run through this method, but you would see that on F# there's a lot of mutable variables because they go inside this while loop and they change over the course of time. We want to retain that value, that change, record it. So I opted to go with mutables in here. The first thing we do on C# is exactly the same thing we do on F#. except that not normal workday length, effective work hours increments, current working date, output date, and allocating working time are all mutable. Let's look at the logic inside the while loop. We start off with a if is holiday current working date. Then we set current working date to get next working day, and we pass in the current working date and compute positively. That's exactly the same thing we do on C#. Then we have an else, and then we check for if it's not within working hours. That's basically the same thing we do on F#. And we have the same condition if it's not within working hours, the current working date. Else, meaning if it is within working hours, we do exactly the same computation. So let's check the flow here step by step. We have current workday length greater than normal workday length. That is exactly the same. We have effective hour increment minus equal effective hour increment minus workday length. That's basically what we do here. Then we check for less or equal to time span 0. That's the same here. And then this, that's that. Then we check for compute positively and set the current and date time value. Then we check if stored workday start time is greater than stored workday stop time. We add to the current end date time, which is exactly what we do. Then there's an else statement in relation to compute positively, and we see that what we do on F# is exactly the same. So there's basically nothing new we add it's just that the syntax is a little different. So in a way, the implementation on C# was pretty, if we can say it like that, functional. Now that we have both implementation complete, we can test them on Visual Studio with unit tests to ensure that we pass the criteria. We end it here. So please stay tuned and remember to subscribe, comment, and press the like button. Thank you.